Hi everyone, I'm Hexadecimal, and this is the second tutorial for creating custom music for Super Mario World ROM hacks. If you've never done this before and you need help getting started from the very beginning, go ahead and check out the first tutorial. I've linked it in the description. For this video, we'll be covering introductions, loops, and optimization. Let's get started. So as a reminder, when we're making SMW music, we write our music as a text file. I'm using Notepad++. We run it in Add Music to create the SBC, the sound file, and we listen to the SBC using SBC 700. I've got a text file here that I've adapted from a track of mine called Happy Accidents. I've shortened it a bit and removed the drums and melodic parts, so we just have the bass line and some of the middle parts. The bass is here in channel 0, line 6. And the chords are in channel 1, 2, and 3. The semicolon marker here is a helpful way to leave a comment without it affecting the end result. This helps remind me that the bass line is in fact in channel 0. So let's listen to it first. Always save before you run. It looks like I'm saved, so I'll just go ahead and run it. All right, so you hear that there's sort of an awkward gap at the end between the bass ending and where it loops back to. And that's because right now I don't have an introduction set. So what I want to do is I want to separate out an introductory measure, basically, so that is not included when it loops back to the beginning. Fortunately, this is really easy to do. We just need to identify the place we want the track to loop back to and put a / there. There's really only one thing that can go wrong here. We need to put the slash in every channel, and we need to make sure we put it in the right place in every channel. These slashes work completely independently of each other, so if you put them in different places in each channel will loop back to a different place, and the channels will get out of sync with each other when they loop back. So here's the place I want it to go back to in channel 0. And if I look before it, I see that there's a half rest, 8th, 8th, 16th, 16th, and an 8th. If I add up all those note values together, I get one whole note, one whole rest, one sort of whole note's worth of music. And that's the amount of music that I want to put before the slash in all the other channels too, so it's the same amount of music. So I'll go down to channel 1, and I'll find one whole note's worth of music. Fortunately, it's really easy to find since these parts are all resting, and I just have one whole rest there, so I'll put the / after that. Now I need to remember to do this for every channel, at least every channel that I'm using, and so I'll go down to channel 2, find that first whole rest, and put the / after that. And one more time for channel 3. This is the last channel that I'm using right now. And if I've done this correctly, not only will it loop back to the right place, but all the parts should loop back to the right place and we should stay in sync. So let's listen. I'll save it. I'll scroll back up to the top here, look at the bass line. And let's run it. go. Great. Sorry, I'll stop that. Yeah, and so that worked the way we wanted it to. It looped back to the right spot, and all the parts stayed together. One more final point about introductions. When you're submitting to SMW Central, the website, if that's something you want to do, one thing they ask for in your submission is the main loop length. And what that means is they're asking for the length of the song, not including the introduction. So let's take a look at our stats document. This is something that's automatically created every time you run your song. I've got it up here already. Since I've done some edits and run it, it's going to ask me, since in Notepad++, if I want to reload it, and I do, just to make sure it's got the update. And here we go. Intro length in seconds, 1.6. Total length in seconds, 35.2. And it's this middle one, the song main loop length in seconds, 33.6. That's the length of the song, not including the introduction. And that's the number that you want to put in with your submission. This stats document is really useful. I go to it all the time. We'll come back to it a bit later for some other stuff. Now, I want to clarify something here. So far, when we've talked about loops, I've been referring to the entire song looping back to the beginning and starting over, so that the whole track, beginning to end, minus the intro, makes one loop. From now on, when I talk about loops, I'll be referring to smaller loops, shorter chunks of music that repeat any number of times within the song. These happen a lot in game music, especially for repeated drum grooves and bass lines, but they can happen in other parts too. And if we want, we can just write these patterns out over and over again, but that takes a lot of work, and perhaps more importantly, it increases our file size. It makes our song unoptimized. We'll talk a lot about optimization at the end, but for now, just know that it's a big deal, and how we handle these small-scale loops can affect optimization a lot. So instead of writing out these repeating patterns every time, we want to find a way to write them out only once or maybe a couple of times, and then tell Add Music to repeat them however many times we need them to repeat. If you read traditional music notation, what we're looking for is an equivalent to a repeat sign. Fortunately, we have exactly that. So here are the looping tools that we have at our disposal. First, we have a single pair of square brackets. And one thing I'm going to do here first is take advantage of a little bit of functionality from our SBC 700 player. You see that we have these channels listed here, 1 through 8. These correspond to channels 0 through 7 in our text file. I only want to hear the bass line right now, so I'm going to mute the rest of these channels. I don't actually have anything in 5, 6, 7, and 8, so it doesn't really matter, but I'll mute them too. Great, so now when I play the song, I'll only hear channel 0, the first channel. So how does this single bracket loop work? Well, you notice here this song starts out in the bass line with the same thing 6 times in a row. So I'll put a bracket around the first time it happens. I can get rid of these last 5 times. And just put a 6 at the end of that bracket. That says how many times we want this particular bracket, this particular repeat to happen. And if I've done this correctly, this should sound exactly the same as what we had before. So let's listen. Always save before you run. Six. Next thing. There we go. That's exactly what we wanted to do. Now, single square brackets have a nice added bit of functionality that you can call them back later in the song. So we can do this in 2 ways. First, we can label it with a number in a set of parentheses. So for instance, I might put a 1 right in front of it like that. Technically, you can put it anywhere before the loop. Basically, the number in parentheses will go looking for the next loop it can find to attach itself to. but it's definitely easier to keep your labels straight if they're right in front of the thing that they're labeling. Be sure that you never use the same number to label more than one thing. Add Music won't know what to do, and you'll get an error. The reason these labels are handy is if you have a loop that comes and goes a lot. So you'll see here that this pattern that we've looped 6 times already comes back here later in the song. So I can actually delete these 2 lines and replace it with our label and tell it, since it happens twice, to repeat twice. Again, this should give me the exact same music I had before. Always save before you run, and here we go. 1, 2, 3, 4, 5, 6, going on. Now back, 1, 2, going on, and so on. So you can hear it's exactly what we had before. Again, it's just much more optimized than it was. So besides labels, the numbers in parentheses, this little 1 here, we can also call back a loop we had previously using an asterisk. The asterisk works exactly the same way as a label, except that you don't designate a specific loop to bring back. It will instead look back to the most recent loop that happened in the music that it can find. So in this case, we could actually use an asterisk. We don't need the label. So I can replace this here with an asterisk. I can get rid of this label if I want to, although it doesn't matter. I can keep it too. And this asterisk will go back looking for whatever loop happened last, which is this one, and it will play that one. Again, this will sound exactly the same as it was before. So I'll save it and run it, and we should get the exact same thing. Six in here. Now back. 2. Going on. There it is. Yeah, same music, just a couple different ways of getting it. One thing to be aware of, there are lots of things that you can change each time something loops back. I can switch instruments, for example, and have the first time through be one instrument and a later time be a different one. So if I changed instruments here on line 16, when it comes back to this asterisk, we'd get the same music, but we'd get a different instrument playing it. You could sorry, you can change things like volume, tempo, vibrato, almost anything really. But the one thing that won't change is pitch or rhythm. In particular, if you change octaves, you see that I have some octave changes here. The loop passage won't change. It will stay in the same octave that it was originally. The new octave designation won't affect anything until the next new music happens. Same thing with the L function. We talked about this in the last video. The L function allows you to designate a rhythmic value that will apply to every note that doesn't already have a number attached to it. So you can write, say, a bunch of 16th notes in a row without putting 16 after every note over and over. If you enter a new L function in between 2 instances of the same loop, again, say right here, it will not change whatever L value you had before. Just like the pitch and the octave, the rhythm inside the loop is fixed and you can't change it. So those are single bracket loops. We also have double bracket loops or super loops. And what's the difference? Most importantly, super loops allow you to nest loops. You can put super loops within regular loops or vice versa. So here you can see I've taken this and I've de-optimized it. I've taken all the loops out. But you'll see that I have music from line 16 to 19 here, which is the same as music from line 21 to 24. So if I want to, I can absolutely put a loop around here, like this, and delete the second instance. And put a 2. so that that part happens twice. Now, but you'll also notice that I have within this loop this line on line 16, which is the same as line 17. So I can put a super loop, a double bracket loop, within my main loop. And get rid of this second one here. And again, I can put a 2 behind it so that it will happen 2 times. So let's listen to this, make sure it gives us exactly what we want. I'll save, and let's run. Here it is, first time through, second time through, going on, now back. First time through, second time through, going on, and going on. There, so I hope that gives you an idea of how that works. We do have one important restriction regarding nesting loops. Regardless of which one you put inside or outside, nesting is not recursive in the sense that you cannot put loops inside loops inside loops. The most you can have is one super loop inside a regular loop, or vice versa. One final thing to watch out for when nesting loops. This is one of the only times where spaces matter. Generally, you'll just add spaces into your code for readability, but it won't affect the outcome. Here it does. Specifically, if your nested loop starts at the same place as your outer loop, that's exactly what's happening here, you can't put the 3 brackets right in a row. So I can't delete that space and have those 3 brackets like that. I need to have a space between my regular loop and my super loop. Otherwise, add music can't tell which is which, and you'll get an error. Now, loops and super loops generally work the same way, but they have some important related differences. First, you cannot call back a super loop. If you want to use the labels or the asterisks that we talked about earlier, you have to use a regular loop, the single bracket loop, instead. Obviously, this means you can only repeat super loops immediately. In fact, you actually have to repeat the super loop. That is, you have to put a number more than one right after the super loop to repeat it. That is right here. If you don't put a number there, you will get an error. But of course, that's fine because you'll want to do this anyway. After all, you can't loop that back remotely, so the only use for a super loop is to repeat it immediately. A super loop without an immediate repeat serves no purpose. So at this point, it just becomes kind of a puzzle. What's the best way to distribute our loops within our text file? And this means we need to talk about optimization. So when we talk about optimization, we're talking about efficiency. How do we get all the notes we want while minimizing our file size? Using loops judiciously is one of the best tools we have for this. As we talked about in tutorial 1, we can find our file size in the stats document, the same document where we found the song duration earlier. But before we go looking for that, we're going to have to take a quick foray into hexadecimal. Now, if you're a programmer or a math geek, hexadecimal is probably old hat, and I strongly encourage you to skip ahead. But if hexadecimal is unfamiliar to you, here's a quick explanation. Basically, hexadecimal is a counting system that works exactly the same way as the decimal system you know and love. The only difference is that while decimal uses base 10, hexadecimal, hex for short, uses base 16. So we've got a chart right here. So in decimal, you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And once you pass 9, you have to add another digit and start over back at 0. In hex, you do the exact same thing, except you count 0, 1, 2, 3, 4 up to 15. And once you pass 15, then you add another digit and start over at 0. The immediate problem is that now we need single character representations for the numbers from 10 to 15. So for those, we use the first 6 letters, A through F. And so A equals 10, B equals 11, and so on up to F equaling 15. You find hex a lot in programming because computers are based on binary base 2 systems. So things tend to work out better when we organize them into powers of 2. So 16 is 2 to the 4th power, which means it's basically like 4 binary operations at once. For our purposes, all you need to know is that these weird-looking combinations of letters and digits are just plain old numbers that happen to be spelled in a slightly different way from what you're used to. It's entirely up to you how fluent you want to become in hex. If you want, you can keep converting things from hex to decimal and back again. It's easy to find converters online. I've got one right here. But even though everything we've done so far in Add Music has been in decimal, you'll be using a lot of hex too. So you'll need to get at least to a reasonably comfortable place with it. With a little practice, it won't be a problem. So, the first hexadecimal number we'll be encountering is the file size. This is the number we want to optimize to make as small as possible. So how does looping help optimize the file? Well, let's compare. So I've taken this file and I've done a lot of loops. I've added a lot of loops to them, not just in the baseline. You can see where I've added them. Here's a label, here's a loop, here's a super loop. But I've done some of that in the lower channels as well. For the mid voices, you can see some loops and labels and super loops there as well. So I've already run this, but I'll just verify that it's ready to go. Run it one more time. Great, we won't listen to the whole thing. Now I'm going to find my stats document, which is right here. It says, do I want to reload it? Yes, I do. And I want to find my song total data size. And you'll see that it's this 02B7. Let's put that into our hex converter here. 02B7. I'll just put 2B7. And convert. And it gives me 695. So that's my optimized version of this file, or at least hopefully a pretty close one. Now let's go back. I've actually prepared an unoptimized version here. This is the original document that we started with at the beginning of the video, where all of these things are written out. So let's run this one. It looks like it's saved, so I can run it right away. It'll sound exactly the same. Great. But I'll go to my stats document for it here. It'll ask me to reload, and I will. And what's the number here? 41C. So let's compare those two. So here's my last one, 2B7, 695. Now I have 41C. You already know this is going to be bigger. And convert. Wow, that's a difference of, by percentage anyway, a huge amount, up to 1052. And you can imagine if we had a longer song where we're using all 8 channels, where we're bringing in external samples, where these differences between optimized and unoptimized can get to be really, really big. One final optimization point about looping. Super loops are actually slightly smaller data-wise than regular loops. So if you're in a situation where you can use either, say you're not nesting loops and you don't need to do a callback, then the super loop is the better choice. So I hope you enjoyed that. I hope you found that useful and that you now understand loops and intros and super loops, and got a little bit of an introduction into how to optimize your file as well. In any case, I hope I'll see you at the next tutorial, and happy porting.